Hello students, we are going to study the topic redox reactions and electrode potential. Okay. So here we are going to study about what? The electrochemical cell or a galvanic cell or a voltaic cell. Okay, all are similar. Okay. What is the function of this electrochemical cell? Actually, it converts the chemical energy into electrical energy. Here, the free energy which is generated during the reaction is used up in making what? The electrical energy. Okay. Here we can see that here total process which will be going on will be in a indirect method, not a direct method. Okay. So how it comes? Let's study. Best example if you take of a galvanic cell is a Daniell cell. Okay. So let us study about the electrochemical reactions in an electrochemical cell. Okay. We are taking here not one container or this container in which the electrolysis is going on, the electrolysis process is going on. We are taking two separate containers. Okay. In one, we are adding a salt solution of zinc. You can take zinc sulfate solution. Okay. Now another, in this we are adding a solution of salt solution of copper. Okay. You can take copper sulfate solutions. Okay. Now two electrodes, one made up of zinc which is dipped in the zinc salt solution, copper dipped in copper salt solution. Okay. Here zinc is acting as anode, copper is acting as cathode. So zinc is negatively charged, this electrode, and this is positively charged. Okay. Now you can see over here these two electrodes are joined by a wire. Okay. Function here through it what? The electron flows, and the current also flows. Okay. Now you can see a bridge like structure which is connected to both the containers in which the process of electrolysis is being done. So here actually what is this bridge? This is known as what? Salt bridge. Okay. Mainly made up of what? What is present in this salt bridge? That is KCl, that is potassium chloride, potassium nitrate, or you can take any other substance also. It is taken. Okay. But yes, in this one more substance is present, that is agar-agar, in which the salt which is present over here is in the paste form. Okay? Got it? Now, here what happens? Zinc. Okay, it comes above in the electrochemical series. Naturally, it will lose the electrons and it will form Zn2+. So now here the two electrons have been released. It moves to the cathode. That is what? Copper. Here you can see this copper sulfate solution, if you have taken, it will be Cu2+ and SO4 2-. Okay. Now this Cu2+ will take up the electrons and get reduced to form copper. Okay. Thereby depositing over here in the cathode. Okay. So here what is happening? Here electrons are being released, isn't it? Zn2+ plus 2 electrons which is moving. Okay. And here the solution also is here, that is zinc sulfate solution. Zinc sulfate solution naturally in aqueous form, isn't it? So here it will be also Zn2+ and SO4 2-. We are seeing what is happening in this container. The zinc ions are going on increasing, isn't it? And here what is happening? The copper ions are being reduced. It is taking the electrons, forming the copper. Here zinc is forming the ions. So naturally what happens? Electrons are flowing, getting deposited over there, or it is taken up by copper ions to form copper. And here you will be seeing that yes, electrons are moving from anode to cathode, isn't it? But yes, what will be the direction of the current? It will be from the cathode to the anode. Okay. Now, so now the electrons are flowing, electricity is also being generated, or current is also being generated. But a time comes when here you will see the accumulation of Zn2 plus ions, and here there will be a shortage of copper ions and sulfate ions will be more. So what happens if this is accumulated? The reaction will stop. But does this happen? No. What happens? Actually here there is a salt bridge, I said to you, made from potassium chloride, potassium nitrate, okay? And here you will be seeing what happens in this. This, suppose if it is KCl, okay, it will be K plus and Cl minus ions. So now what will happen? Here Zn2 plus ions are being accommodated. So positive ions are accommodated, okay, and as a result negative ions are less. So what will happen? Cl will move towards, Cl minus ions will move towards where the zinc ions are being accumulated, okay, to neutralize the charge. Now see about what potassium. Here sulfate ions are being accommodated. These are negatively charged. Naturally K plus ions will move towards this side, okay, thereby maintaining the electrical neutrality. So what is the function of this salt bridge? It maintains the electrical neutrality of the cell, okay. If it is not present, the reaction will stop after certain time, okay, and as well as it maintains the continuity of the reaction, and that is the function of what? The salt bridge. So this is about the electrochemical cell, how it functions and how it works, and the function of the salt bridge. Now electrode potential, what is this? It is the tendency of an electrode to lose or gain electrons when it is in contact with its own ions in the solution. Like right now we have studied in the electrochemical cell, the zinc electrode being in contact with its own ions, that is ZnSO4, Zn2 plus and SO4 minus. Right now I have said to you, copper also you have seen, isn't it? So here actually what is its tendency, whether it is giving the electrons or it is gaining the electrons when it is in contact with its own ions in the solution. Okay, so this is of two types, oxidation potential and reduction potential. When I am talking about oxidation potential, you have seen that here when the zinc rod is being dipped in ZnSO4 solution, we have seen at anode, what happened? It has lost electrons, isn't it? So what has happened over there? Oxidation potential, okay. Reduction potential, what did you see? The copper, okay, which was in contact with its own solution, CuSO4, okay. What happened in that? They had taken that electrode, copper has taken, what? The electrons got reduced. What is that? Reduction potential, okay. Now standard electrode potential. Standard electrode potential is electrode potential only, but the word here is coming what? Standard. What is this standard? Standard means something which has got specific concentration, temperature and pressure if it is a gas. Okay, so in standard condition, what happened? The concentration should be unity or 1 m. This m here represents molarity, okay, and temperature should be 298 Kelvin. And yes, if it is a gas, the pressure should be 1 atmospheric pressure. That explains standard electrode potential. So now natural hydrogen electrode or standard hydrogen electrode. Okay, you can write in short form, it is written as NHE or SHE. Okay, now actually this is used to determine, okay, what? The electrode potential of any unknown electrode. Why? Here, why we are saying it as normal hydrogen electrode or standard hydrogen electrode. Here we are seeing, this is the total SHE, that is the standard hydrogen electrode, okay. What we are seeing here, it is a platinum, you can see, it is coated with platinum actually, okay. And here you can see the solution, this is a solution of its own, that is you can take HCl. Okay, it is written 1m HCl. If I am writing 1m, it means what? Unity, and it is in standard condition. Okay, here temperature written 298 Kelvin. Okay, standard condition of temperature. 1 atmospheric pressure, standard condition of pressure if we are taking gas, because here we are bubbling what? Hydrogen gas in it. So this standard hydrogen electrode can act as what? Cathode also, or it can act as anode also. It depends with what it is being connected. Okay, suppose if it is being connected, okay, with zinc, okay, zinc electrode, this standard hydrogen electrode, so naturally what will happen here? In this, the reduction potential will take place. It will accept the electrons because zinc come in the reactivity series in the top position. So regarding Shear, we have studied, yes, if we are attaching this standard hydrogen electrode to zinc, it comes above in the activity series, and naturally here what will happen? This will be, she will be acting as what? It will be taking the electrons. So here what will be happening? Reduction will be taking place. So it will be acting as the reduction half only. Okay, if we are adding it to copper, copper is below hydrogen, so naturally what will happen? In this, now hydrogen will lose the electrons, okay, and it will be acting as what? Oxidation half. Okay, now coming to the cell potential or EMF of the cell. What is this? This is the potential difference between the two electrodes of the galvanic cell. Okay, it can be calculated, and it is written as E cell, that is equal to E cathode minus E anode. If we are taking in standard condition, naturally standard condition means what? 1m concentration, temperature 298 Kelvin, and if it is a gas, then pressure will be 1 atmospheric pressure. Okay, so if we are taking this cell potential in the standard condition, we will be adding naught over here. Okay, so E naught cell is equal to what? So in standard conditions you will be writing in this manner. Okay, E naught cathode minus E naught anode. Okay, now coming to redox couple. What is this redox couple actually? It is a combination of oxidized and the reduced form of the same substance, okay, which is taking part in what? The oxidation and reduction half reaction. Okay, like if we are taking zinc, okay, here what is there? Zn2 plus, what is happening? Oxidation is taking place, isn't it? Losing the electrons in one half reaction, another you are writing zinc. So this is what? The oxidation half, this is reduction half, and this is known as what? A redox couple. So with this we come to the end of the chapter redox reactions. Hope students you might have understood it. Good day, take care.